Creating a travel time curve, also known as a seismic travel time curve, involves plotting the arrival times of seismic waves recorded at different distance from a seismic events. These curves are essential in seismology for determining the earthquake's epicenter, magnitude, and depth. Here is a step-by-step guide to creating a travel time curve. Gather data. Collect seismic data from seismographs located at various distance from the Earth epicenter. Seismic data typically include the arrival times of different types of seismic waves, such as P waves, primary waves, and S wave, secondary waves, recorded at each seismograph station. Determine distance. Calculate the epicentral distance between each seismograph station and the earthquake epicenter. This distance is crucial for plotting the travel time curve accurately. You can use geographical coordinates and seismic station location to compute these distances. Calculate travel times. Use seismic wave velocity information to calculate the theoretical arrival times of P waves and S waves at each seismograph station. The travel times will depend on seismic wave velocity in different layers of the Earth, which varies with depth and composition. Plotting the curve. On a graph paper, plot the epicentral distance, the x-axis, against the arrival time of seismic wave, the y-axis. Plot separate curves for P waves and S waves. P waves typically arrive first, followed by S waves. Interpretation. Analyze the travel time curve to determine the earthquake's epicenter and magnitude. The intersection point of the P wave and S wave curve represent the epicenter, and the vertical distance between the curves indicate the time interval between P wave and S wave arrivals, which is used to estimate the earthquake's depth. Magnitude can also be estimated based on the time interval and the amplitude of seismic waves. Modification and validation. Validate the travel time curve by comparing it with data from multiple seismic stations and refining it as needed. Consider factors such as seismic wave velocity variations due to the Earth structure and the accuracy of arrival time measurements. Application. Use the travel time curve and seismic data for further seismic analysis, including earthquake monitoring, hazard assessment, and earthquake source characterization. Creating a travel time curve requires careful data collection, analysis, and interpretation. It is a fundamental tool in seismology for understanding earthquake behavior and assessing seismic hazard.